Here is one of those unique geometry challenges. To solve it, you will need four famous theorems: the perpendicular bisector of chord theorem, the intersecting chord theorem, Taylor's theorem, and the Pythagorean theorem. Hey everyone, welcome to Geomatic. We have a circle with three lines drawn inside it. One line, which is a small chord of the circle, measures 11 units. Another line perpendicular to this chord measures 4 units. And the other one 16 units long, perpendicular to 4 units line. And we need to figure out the circle's radius using the data provided. Let's start by considering this point is the center of a circle. And then, to make things easier, I prefer to label this point with letters. So A, B, C, and D. Next, from this point B, we draw a line perpendicular to DC and form a rectangle. Then name this point E. As we know, opposite sides of rectangle are equal. By doing this, we mark 11 units along DC. So DE equals 11, exactly like AB, because we know the opposite sides in a rectangle are equal and parallel. We know DC equals 16. So if this part is 11, the remaining segment of DC is 16 minus 11 equals 5. So this part equals 5. EC equals 5. Now we draw a line from the considered center perpendicular to AB. Since AB and DE are parallel, this line is perpendicular to both of them. So this line is perpendicular to DE as well. And this is where our first theorem comes into play, the perpendicular bisector of chord theorem, which says if you draw a line from the center of a circle perpendicular to any chords inside the circle, it will always divide that into two equal parts. So we can conclude this part is equal to this part, and since DE and AB are two opposite sides of a rectangle, this segment equals this one equals this and this one. Now if we extend the line CD to the circumference of the circle like this and name it F, it also forms a chord of the circle. So CF is a chord of the circle. Thus the line drawn from the center perpendicular to AB is likewise perpendicular to this neochord and bisects it. So I name this point as G. We know that DE is equal to AB, which is 11 units. Since point G divides line CF into two equal parts, FG and CG, and DG is equal to GE. So FD, this part, must be equal to CE, this part. And we already know that CE is 5 units, so FD is 5 units as well. In the next step, we extend line AD to meet the circumference of the circle and name this point as H. Now, how can we find the length of HD? Easy, we use our second theorem, the intersecting chord theorem, which says if two chords intersect inside the circle, the two segments of one chord times each other equals the two segments of the other chords times each other. Means FD times CD equals AD times HD. So I write that FD times CD equals AD times HD. We know FD equals 5 and CD equals 16. So 5 times 16 equals AD equals 4 times HD. Then HD equals 5 times 16 over 4 is equal to 20. So HD equals 20. Next, we draw a line from point B to the point H, which forms the circle's diameter passing through the center. But how can we be certain that this line passes through the center and is indeed the diameter? Yes, we use the Taylor's theorem. According to this rule, when a right triangle has all three vertices on the circle's circumference A, B, H, then its hypotenuse is the circle's diameter and passes through the center. In other words, if a right angle like A is inscribed in a circle, the arc opposite it is twice the angle, means 180 degrees. So the side opposite the right angle can only be the diameter. And finally, it's time to use our last theorem, probably the most famous one, Pythagorean theorem. Now we have a right triangle with two known sides, AH and AB. And we need to find its hypotenuse, which is also the circle's diameter. So we have AH equals 4 plus 20. AH equals 24. And AB, as we have, equals 11. The diameter is twice the radius, so 2r squared equals 11 squared plus 24 squared. Then we have 2r equals the square root of 11 squared plus 24 squared, which is equal to the square root of 697. Approximately equals 26.4. Then the radius equals, of course, approximately equals 26.4 over 2 equals 13.2. I really appreciate you if you solve this problem in your way and let me know in comments. Have a good time.